Alright, in this video we're going to take a look at special right triangles, and in this video I'm going to specifically take a look at 45, 45, 90 triangles, and I'm going to save the 30, 60, 90 triangles for another video. Now 45, 45, 90s, the reason they're so special is because they have unique properties just in relation to their sides. Again, you have your 90-degree angle for your right triangle, and you have two 45-degree angles. And this makes a total of 180 degrees. But that's not what's special. If you focus on what I have here, if you can draw this triangle out and try to remember this, it really comes in handy for when you're given problems and you're trying to find what goes where, which sides or what lengths. All this says is your legs of your right triangle will always have the same length, especially if it's 45, 45s. Suppose x is 5. If this side is 5, then this side is 5. And if I want to know what the hypotenuse is, I don't have to do my Pythagorean theorem. I can simply tack on a radical 2 to the 5. So, I mean, if this was 8 and 8, my hypotenuse would be 8 times radical 2. That would be the length, 8 radical 2. So, without further ado, let's take a look at a few problems. I'm going to take a look at 4 examples. Hopefully that'll be enough, but example 1, let me just zoom in so we're not cramming all these. Example 1, we're given a 45, 45, 90 triangle, and we're trying to find the value of x and the value of y. Again, I always try to remember these. It's useful if you can draw these out, but again, I know my two legs should always be the same length, x and x. So, if I know this is a length of 2, this should also be a length of 2. It's that easy. 2, 2, and so what's y going to be? Well, if you want to figure what that is, you can simply tack on, you can take your 2, which is your x, 2, and then tack on a radical 2 to that. 2 times radical 2. So y is equal to 2 times radical 2. That would be the length. Let's take a look at example 2. Example 2, we're given a length of 15 for one of our legs. So if this is a 45, 45, 90 triangle, this should also be 15. And now, what does my right triangle tell me to do? It tells 15, 15. This is going to be 15 radical 2. It's that easy. Now, example 3 works a little bit differently. A lot of students tend to get confused on this. And if you observe what you're given, well, we weren't given what my legs were, right? Because normally if this was, like the last example, it was 15, 15, 15 radical 2, right? It's not that simple because all I'm given now is my hypotenuse, and that's a length of 10. If you look at your special right triangle, like the formula for it, this is equal to 10 right now, right? The hypotenuse is equal to 10. But that is x times radical 2. So how do we find what x is? Well, there's an easy way to do it, especially for those of you who don't really like rationalizing and even thinking about it too much. There's a little trick you can do. I simply take whatever this number is, I cut it in half. So 10 divided by 2 is going to give me 5. And I'm going to tack on a radical 2 to that. It's that simple. You take this number, 10, you're going to cut it in half, divided by 2, that gives you 5, and then you take this number and you multiply it times radical 2, and that's going to be the leg. So this is 5 radical 2, and this is going to be 5 radical 2. It's that simple. Alright, so now let's take a look at the final example that I have prepared. Again, we're given the hypotenuse, not the leg, so we're trying to figure out what our legs are. Now, use the trick that I did before. What should you be doing? Remember, in this example, I took my hypotenuse, 10, and I cut it in half. It gave me 5, right? You should do the same thing here. If you want to avoid all the hassle, take 8, cut it in half. What do you end up getting? Well, that'll give me 4. And then what do? What did I end up doing here? I tacked on a radical 2 to the very end, right? You should do the same thing here. So your legs are going to be 4 times radical 2. This is going to be 4 times radical 2. And that's it. That's really the only types of problems that I could really think of for 45, 45, 90s. These are the ones that you should try to practice, especially when you're given a hypotenuse first. The other ones aren't that terrible. All you have to do is, if you're given one of the legs, if this was 15 or 18, it doesn't matter, 18, 18, 18 times radical 2. If this was 6, then this would be 6, 6, 6 radical 2. And it all comes back to your special right triangle formulas. It's not really a formula, but it just tells you where everything goes and puts everything in perspective. So hopefully this helps.